Light. People and other animals can see because there is light. Light is a form of energy. The sun is a very important source of light energy. These are the sources of light. So, types of light sources. There's natural light sources like the sun, and there's artificial light sources like a candle. So two types of light, two sources of light. So here's some natural light sources. The sun is the major source of light for the earth. The sun is a star. You can kind of just see some things about the sun, what it might look like at the core and the inside. Another source of natural light is fire and lightning. Bioluminescence is it's another type of natural light source. Some plants and animals have the ability to produce light too. It is called bioluminescence. That's when something can create its own light. I wish I could do that. All of these plants and animals have bioluminescence. That's just one of the pictures I thought looked really cool. It shows a picture of bioluminescence. Do you remember what it means? They have the ability to produce light. Okay, jellyfish. You can see a picture there. There's dark all around them except them. They're light. Fireflies. Algae. And so you can see the algae, which is an organism. It's kind of like a plant, so it has chlorophyll and it uses energy from the sun to make its own food. And so this one has the ability to make its own light also. And some fungus. You can see it's making its own light as well. And then remember, we have natural light and artificial light. So these are the types, just some of the types of artificial light. And I like this picture because it shows these plants are growing in artificial light or natural light? If they were out in the sun, they would be in natural light, but they're under some lamps, so it's artificial light. Light bulbs, flashlight, candles. And here's some properties of light. And we'll learn more about this in a minute. Photons and waves. Photons are very small light particles that are invisible to the eye. Photons move in waves. So the waves are made up of little particles called photons. The color of light depends on its wavelength. So we can see the wavelengths here. You can see red is over here, and violet or purple is over here, and so this is short and long. Red light has the longest wavelength, and we just saw that up here, where it is. Okay, and you'll notice it's stacked, it looks like a rainbow, right? Violet light has the shortest wavelength, and it's right there. Orange, yellow, green, blue, and indigo have wavelengths in between those of red and violet. And so you see them there. And if you haven't heard that word indigo before, could you tell me what it means from looking at this? You could see that it's not quite blue and it's not quite purple, right? So it's a mixture of blue and purple. When light waves of all the colors travel together, the light looks white. Now let's watch this video. That kind of explains it a little bit better.
White light is defined as the complete mixture of all of the wavelengths of the visible spectrum. This means that if I have beams of light of all of the colors of the rainbow and focus all of the colors onto a single spot, the combination of all of the colors will result in a beam of white light. White light can be generated by a variety of sources both in space and by artificial sources on Earth. For example, the sun and other stars are sources of white light. The sun is the most obvious source of white light in our solar system. As for artificial sources, fluorescent light bulbs and white LEDs produce white light. Other light bulbs, like the incandescent lamp, do not produce white light. They produce light of much longer wavelengths along the yellow to red range.
Certain objects, such as triangular pieces of glass called prisms, can separate white light into the individual colors. And so we just learned a little bit about that. But let's look at this. When light travels through a prism, waves of different wavelengths bend by different amounts. The color of each wavelength then appears separately. This effect is called a spectrum. A rainbow is a type of spectrum. Did you know that? When raindrops make a rainbow, they are acting like prisms. And so, remember I told you we learned a little bit more about that? Now you know what that means. So if all of these wavelengths and photons are together, it looks white. But if you get a prism, it makes the wavelengths bend, and so you can see them separately. Pretty cool, huh? And we'll watch one more video so that you know a little bit more about light, and then we'll be done.
Light is a strange thing. It isn't just what we can see. Light can be broken up into different types, and we call the whole family the electromagnetic spectrum. So even when it's dark, light is still all around us. Light can be created by making an electron oscillate. This creates an oscillating magnetic field and an oscillating electric field, which we call an electromagnetic wave or light. We often represent light as a wave. Just like water waves, light has a wavelength, a frequency, and a speed. The different colours of optical light have different wavelengths, and so does the rest of the electromagnetic spectrum. Gamma rays are the most energetic, whereas radio waves have the least energy. Even so, light is the fastest thing in the universe. In a vacuum, all light waves, even radio waves, travel at an incredible speed of 300 million meters per second. The Royal Observatory is overrun with squirrels. They're hard to miss during the day because they reflect visible light from the sun, but at night it's more difficult. However, they do emit infrared light, and if our eyes could detect it, we would be able to see them in the dark. If we pass high-energy X-rays through them, the squirrels look very different. Humankind has invented lots of different instruments to show us what our eyes can't see, like our Great Equatorial Telescope, which captures huge amounts of light and allows us to see objects that are tens of millions of trillions of kilometers away. We can see matter interact with light and change it. The gases in the Earth's atmosphere scatter blue wavelengths of sunlight, giving us blue skies during the day and red skies at sunrise and sunset. We can watch sunlight reflect off planets and the moon. During a lunar eclipse, red sunlight changes direction as it passes through the Earth's atmosphere and reaches the moon. And although visible light from stars can be absorbed by dust in space, we can detect the infrared light, which gets through to see baby stars hiding in nebulae. Light can even appear to stretch out. Since our universe is expanding and galaxies are moving away from each other, the light they emit is stretched to longer wavelengths. We call this redshift. Some galaxies are so far away that their light has shifted and stretched from visible to infrared, so we can no longer see them. Stranger still, The universe has unknown amounts of dark matter and bizarre black holes, so even if we can detect all the different types of light, there are still some things in the universe that will remain invisible to us.